Primordial black holes, the ancient ghosts. Primordial black holes are thought to be among the earliest objects in the universe. Unlike other black holes, which form from collapsing stars, these may have been created just moments after the Big Bang, when matter was so dense that pockets of space collapsed under their own gravity. These black holes could be as small as an atom, but hold the mass of a mountain. Because of their size, they wouldn't be detected the same way as normal black holes. Some scientists have even suggested they could account for part of the mysterious dark matter that makes up most of the universe. If true, it means black holes have been haunting the cosmos since the very beginning. Micro-black holes, tiny but lethal. Micro-black holes, sometimes called quantum black holes, are theoretical. They would be incredibly small, smaller than a proton, but with immense density. In theory, they could form in high-energy environments like inside particle accelerators or during violent cosmic collisions. The terrifying thing about micro-black holes is that, despite their size, their gravity would still be extreme. If one formed on Earth and didn't evaporate instantly through Hawking radiation, it could start swallowing matter atom by atom. Luckily, all the math suggests they would vanish almost immediately. But just the thought of microscopic cosmic vacuum cleaners popping into existence is chilling. Stellar mass black holes, the common killers. These are the black holes we know best. Stellar mass black holes form when massive stars, at least 20 times the mass of the Sun, run out of fuel and collapse under their own gravity. What's left behind is an object so dense that not even light can escape. Most stellar black holes are between 5 and 20 solar masses, but their destructive power is massive. If one were to pass near our solar system, it could rip planets apart and shred the Earth through tidal forces. There may be millions of these lurking in our galaxy alone, silent predators we can only detect when they feed on nearby stars and emit powerful X-rays. Intermediate black holes, the missing links. Intermediate black holes sit in the gray area between stellar black holes and supermassive ones. They're thought to have masses between 100 and 100,000 suns. Astronomers have found hints of them in globular clusters and dwarf galaxies, but they're elusive and difficult to confirm. What makes them terrifying is their role as cosmic wrecking balls. If an intermediate black hole drifts through a star cluster, it can destabilize entire systems, swallowing stars or flinging them into intergalactic space. Many scientists think these middleweight black holes could be the building blocks of the gigantic black holes found in galaxy centers. Supermassive black holes, the galactic giants. At the core of nearly every galaxy lies a supermassive black hole. These monsters have masses ranging from millions to billions of suns. Our own Milky Way houses one called Sagittarius A*, which weighs in at about 4 million solar masses. Supermassive black holes control the fate of their entire galaxies. Their gravity shapes the orbits of billions of stars, and when they feed, they unleash titanic amounts of energy, sometimes outshining all the stars in their galaxy combined. Quasars, the brightest objects in the universe, are powered by supermassive black holes devouring matter at incredible rates. Imagine standing near one of these giants. Time itself would slow down for you compared to the rest of the universe. From a safe distance, they're awe-inspiring. Up close, they're cosmic annihilation. Ultramassive black holes, beyond imagination. If supermassive black holes sound terrifying, ultramassive black holes take things to the next level. These are the biggest black holes ever discovered, with masses reaching tens of billions of suns. One record holder, known as TON 618, has an estimated mass of 66 billion solar masses. The event horizon of a black hole this large would stretch wider than our entire solar system. If TON 618 were placed where our Sun is, its edge would engulf every planet out to Neptune. Black holes on this scale are so immense that they defy imagination, warping space and time on scales we can barely comprehend. Spinning, Kerr black holes, the cosmic blenders. Not all black holes are the same in behavior. Some are spinning at incredible speeds. Known as Kerr black holes, these rotate so quickly that they drag space-time itself around with them in a phenomenon called frame dragging. This rotation allows them to store enormous amounts of energy. In theory, advanced civilizations could harness this power by tapping into the black hole's spin through a process called the Penrose mechanism. But for anything unlucky enough to fall in, the spinning creates chaotic and violent conditions, shredding matter before it crosses the horizon. Charge, Reisner-Nordstrom, black holes, the exotic oddities. Charged black holes are mostly theoretical, but they add another layer of strangeness. These would carry an electric charge, which dramatically changes their structure compared to normal black holes. Instead of a single event horizon, they might have two, creating bizarre effects in how matter and light behave near them. In reality, most charged black holes would likely neutralize quickly by attracting opposite charges. But on paper, they reveal just how weird black holes can get, objects so extreme that even the laws of physics stretch to the breaking point. Binary black holes, the double killers. Sometimes black holes come in pairs. Binary black holes orbit one another in a deadly cosmic dance, spiraling closer over millions of years until they eventually merge in a cataclysmic explosion. When this happens, they release enormous gravitational waves, ripples in space-time first detected by LIGO in 2015. The idea of two invisible monsters locked in orbit, each warping space and time, is terrifying on its own. But the fact that their collision can literally shake the fabric of the universe shows just how powerful they are. Quasars and active galactic nuclei, black holes on fire. When supermassive black holes feed aggressively, they enter a phase known as a quasar or an active galactic nucleus. These aren't entirely new categories of black holes, but rather a stage in their life cycle when they flare into existence as some of the brightest and most energetic objects in the cosmos. In this state, the black hole's immense gravity pulls in surrounding gas, dust, and even stars, forming a whirling accretion disk around it. As this material spirals inward, it's compressed and heated to extreme temperatures, often millions of degrees, producing a dazzling amount of radiation that can span the entire electromagnetic spectrum, from radio waves to powerful X-rays. The intense magnetic fields generated near the black hole can also funnel some of this energy outward, launching colossal jets of plasma that stretch for thousands or even millions of light years into intergalactic space. The result is a beacon so bright that a single quasar can outshine not only its host galaxy, but also billions of stars combined. This raw energy output makes quasars valuable cosmic lighthouses for astronomers, allowing them to peer back in time and study the early universe. Theoretical white holes. The opposites, white holes, are the subject of one speculative theoretical proposition. These would be the complete opposite of black holes. Rather than drawing matter in, they would expel it and would never allow anything to enter. Wormholes, which are hypothesized to connect black holes and white holes, could potentially serve as shortcuts that allow for travel throughout the universe, according to certain ideas. Despite the fact that white holes had not yet been shown to exist, the discovery of their existence would entail a significant reworking of our concept of space and time. Putting all of the elements into context, black holes occur in a broader diversity of terrifying forms than most people would ever think possible. They range in size from small primordial specters to colossal cosmic monsters. Not only are they vacuum cleaners of the cosmos, they are also engines of destruction, shapers of galaxies, and they may even be the key to understanding the universe's fundamental laws. New information about the boundaries of the cosmos is revealed to us by each type of black hole. They remind us that the region that is beyond our small blue planet is not a vacuum. There is not a single item that exists in space.